Welcome, ladies and gentlemen, to this video lecture. So now we will start a new section on one-sided limits. And as before, we will give the rigorous definition of a one-sided limit. So let's write down the definition. So let f be some function defined on the open interval a to b to the real numbers. Then the following, so the limit as x tends to a from the right, so this is how we write it, x tends to a plus, and this a plus denotes that x tends to a from the right, of f of x is equal to L, where of course L is some real number. This means, and the definition is very similar to the definition of a regular limit. So this means the following: for every epsilon greater than 0, there exists a delta greater than 0, so that if, and now this condition changes, so if x is to the right of a but still within a delta distance of a, so is in the interval from a to a plus delta, then the distance of the function value to L is less than epsilon. So the idea here is, if you've got some function defined on an open interval from a to b, let's say the function looks something, the graph of the function looks something like this, and like so. L is over there. So what this says is, if you look at this strip of radius epsilon, so that will be the top part will be L plus epsilon, the bottom part will be L minus epsilon. So it doesn't matter how big or how small you take this epsilon, you should always be able to find a delta. So you should always be able to find a delta, for example like so, so that if you are in this interval from a to a plus delta, if you are in this interval, then all the function values are within an epsilon distance of L, meaning all the function values lie within this strip of radius epsilon around L. So that is for a right limit. So as x tends to a from the right equal to L means this. Okay, and of course symmetrically you have a left limit. So the following, the limit as x tends to b from the left of f of x is equal to L. That means the following. Means for every epsilon greater than 0, there exists a delta greater than 0, so that if we are now to the left of b but still within a delta distance, so that if we are to the left of b, so if x is smaller than b but greater than b minus delta, then we have that the function value at x of f is within an epsilon distance of L. And of course, what does that mean? That means, if we think about it, if that is A, that is B, This means that we are in some interval to the left of b. So let's just think about intuitively what this means. Let's say we have some function f whose graph looks like that. Let's say the limiting value is L. Then if we read this definition, it says for every epsilon, so it doesn't matter what the value of epsilon is. So for any epsilon, if you look at this strip centered at L but of radius epsilon, if you look at that strip, you should be able to find a delta, so that if you look at this interval from delta minus b, b minus delta to b, if you look at this interval, for every x in this interval, the function value lies inside of this epsilon strip around L. Okay, so that is the definition of one-sided limits. You see, it is very similar to the normal definition of the limit. The only difference is in this condition on the x. So we restrict ourselves to one side of the point that we are interested in, whereas in the normal definition of the limit we looked at both sides. So the only difference is encoded in the hypothesis of these implications. Okay, I will see you in the next one, where we will do an example.